So this presentation will be about, is actually a compression of the whole master's units that I teach on smart systems. And it is contains all of the important points of this unit. It is based on SysML, and it is using a professional tool, the magic system of systems architect. And it has originated, some parts of it, from research that was done collaboratively with the autonomics team at BT. But after some point, when we didn't actually continue that stream of research, and it was considered a bit easier, it was fed into the teaching. So all of these patterns and these ideas started from autonomics research, so that I give them the references of how this work has originated. So in this presentation and in this training, I'll try to make you SysML experts in an hour to understand the important diagrams, but especially for smart adaptive systems, and especially for using adaptivity patterns, which is the smart adaptive part of the training. And you will get some initiation to the professional tool, and I will demonstrate how you do things. I have also some pre-recording videos because I wasn't 100% sure that the remote connections with the university might work today. So I have this option as well, and it is included in the slides, as well as recording this presentation. And by the end of it, you should have a good understanding of how of the SysML language, of the adaptivity, and of the using a professional tool in a master's classroom. Well, I was one slide behind while I was talking on the previous one. These are the purposes of the course. And at the end of it, we are going to reflect on the use of the professional tool and the requirements that would be good for someone to know once they graduate university to be able to handle this type of tools. I have to know that this 1 hour and a half session is only touching part of it, because the professional tool is actually has a lot more features that are covered in what I'm going to discuss, and a lot more depth. And we are going to reflect at the end on the positives that someone gets from this experience, and on the elements that would require for educational reasons, purposes as well. First of all, a bit of terminology. I was given to teach that unit 3 or 4 years ago with just the title Smart Systems. I added the adaptive in it because it was giving the opportunity to use these adaptivity patterns in the teaching. The adaptivity patterns have been the biggest problem in the teaching in the unit, and very rarely students get it and achieve in it. However, I'm improving my methods, and I hope I'll get a feel of how this goes with this with other audiences. I am happy for you to stop me, and I would be very happy actually if you stop me along the way, because that will not be me talking by myself at my office for 1 hour and a half. So feel free to stop and discuss at any point. So first of all, the terminology, smart systems. We usually consider the systems where there are some sensors, and usually hardware sensors. So it has started from the world of cyber physical systems, where you have sensors collecting information. So all of this goes towards Internet of Things and this type of applications. However, a sensor is not always a hard sensor. There are software sensors for collecting information. And generally, with the term sensor, we mean anything that collects information. So that is the smart part. But this discussion here is not at the level where we are choosing specific sensors and we are talking about the specifics of an architecture based on this technology. It's a higher level of description, and that's where the adaptive part comes in, where we look at how you utilize the information that you collect from a smart intelligent system, and you create a system that is able to adapt itself. All of the adaptive work is based on the MAP-K loop, which is a standard architecture for adaptive or autonomic systems. There is controversy in the definitions of the words, and please, if I use them randomly, correct me. Generally, the MAP-K idea is that you have three elements. You monitor the environment, you analyze what you are collecting, you plan and decide what changes you need to make. And in all of this idea, you have data where you store and you take information from. This seems an oversimplified way of discussing about it, and the MAP-K architecture is something initiated by IBM white paper some years ago, and it has a lot more depth into just following a loop of monitor adaptation and adaptation context. But for example, multiple of these you might have to use in your architecture, but for simplicity and for purposes of the masters where I teach this, I just present the MAP-K as one loop that happens once. Sorry, I've started running uncontrollably. There is some work which has been done by Andres Ramirez, and it's a very well-cited work. It is from a master's thesis, and I think he is at the research team of Professor Cheng, if I'm not mistaken. Anyway, that work consists of several adaptivity patterns where in that master thesis, it's around 150 pages, and it is actually categorizing adaptivity patterns in three big categories: the monitoring, decision-making, and the configuration patterns. So together with me trying to get you through to see the professional tool and the SysML, a major part of the training will be to apply these patterns, and I would like your honest feedback, because that is the tricky point that students are not getting in the masters year after year, with some rare exceptions. Actually, only if I remove the number of patterns that I teach, the 150 pages, if I actually restrict it to 20 pages, then I have managed to achieve some teaching on this. These are all the patterns that are described in this thesis, and there are detailed descriptions. There are also they are patterns in order to define adaptivity mechanisms. So you can see here the monitoring patterns. There are three options: the sensor factory, the reflective monitor, and the content-based routing. These are ideas. Content-based routing, for example, is idea that has originated from networks. There are ideas even from other fields, and they are formulated and presented using UML diagrams, UML class diagrams, and UML sequence diagrams. We will see some important patterns here, and part of the work will be to try to apply them in the design so that the design that you do in SysML actually has adaptivity at the architecture level and not at the lower levels. And probably I will go, as I move on, I will go more into that. This is a short introduction about block diagrams. I'll probably, if I look at my audience, I think it seems to be quite experienced, so I think I'll skip through it quite quickly. The block diagrams is the SysML way of defining class diagrams, and they are kind of stripped class diagrams that are targeted to systems. The class diagrams have been defined in UML for years and used, but they have been identified for being very good for software. Block diagrams is their replacement by SysML in order to describe things that are beyond software and in order to be able to describe anything. This is an example of a block diagram, and this is a lot more talking about what I try to discuss. They have both structural and behavioral characteristics. The structural characteristics are as they are in the class diagrams as well, and the behavioral characteristics, again, are operations, receptions, and interfaces. And what we are going to see in this training is how the structural diagram like the block is being connected automatically with a behavioral diagram like a sequence diagram automatically by the tool. So the relationships that exist in the block diagrams are mainly three: the part, the shared, and the reference, and the generalizations. And this is an example. So it's kind of a simplified class diagram. And these are some intricacies of the language. The shared association is the same as the aggregation, where you are actually using optional connection between your blocks, whereas in the part association, the connection has to be there. The reference association, again, is an association that you use in UML as well, where we define that two blocks, they are referenced to each other. And the generalization is when you have the inheritance. So I suspect you know all this. So I'm going to move quickly to the sequence diagrams, and then we'll go into practical things as well. The sequence diagrams are exactly the same as the sequence diagrams in UML. They are here to model behavior. What is very important when we teach this modeling is that not only when we teach, when people are trying to do model-based engineering, is that a lot of people are doing SysML block diagrams with behavior in mind. So all of these elements here that you see, a common mistake is that people are using from the block here to other blocks, they use arrows to depict that there is behavior. That's the most common mistake that we notice in our year 2 unit in everything. And I have noticed that with engineers as well, where they draw something as a diagram and the flow between one block to the other is not actually a structural thing in the block diagram, it's actually a behavior. So a lot of importance needs to be made on the fact that we have structure and behavior in separate diagrams, and they are connecting between them with the operations and with automatic ways and common naming. But you will understand that more if you see it in practice, and we are going to do some practical too. Unfortunately, I had secured at some point for the participants of the workshop to get a 1 month trial of this, but we didn't manage to do it on time for the workshop. However, they have told me that if I have the MAC IP addresses and ask Magic Systems of Systems, then they will give a free trial for a month. So please send the MAC IP addresses and we can sort it out so that you can try the Magic System of Systems on your own to see what we are going to discuss. For the purposes of the workshop, I will demonstrate things as I will demonstrate live how you do it. So you, as a contribution to this, so that you can see how easy or difficult or intrusive or non-intrusive using the tool can be. This is a sequence diagram, which is actually standard the same way as it is in UML. I like this example because it has all the notation all at once, like parallel, loops, optional, and it has absolutely everything. So using this diagram, you can actually see what exists in the SysML sequence diagrams. And another important thing that would be good to know and for sequence diagrams is that there are two types of messages. There are synchronous and asynchronous messages. And that what is the differentiation if someone knows the proper notation or not. If they don't actually know the properly the notation, they just use an arrow between anything here without really differentiating between this type of arrow and that type of arrow. And I have seen that in many projects actually that are even European projects, people using the sequence diagrams with one type of arrow, not understanding the difference between synchronous and asynchronous. This is a very quick guide where it tells you the difference between them. The synchronous message is the sender waits for a response. The asynchronous, it sends the response and that's it, doesn't wait, continues. And that's all you need actually to do some good sequence diagrams. I won't go anymore into that because I would like to think that the audience understands this a lot. I don't know why I cannot find the file, but I will describe it. Anyway, are there any questions up to now? Okay. Have you slept, all of you? No?
Nope.
Okay.
Still here.
Okay, that's good then.
Yeah, still here.
Thanks, Dimitris. Yes. Okay, so we learned our SysML in 20 minutes, and we are moving on now into how to apply the specific case study. For some reason, I have moved my file somewhere else. So if you wait a minute, I will find the correct file. So this is a case study that I use in the master's class, and the idea is about giving the students English text like this, and this English text is they have to analyze it and create diagrams and provide a solution, and also apply the adaptivity patterns in their solution. And the case study is personalized education, where you have a virtual learning environment which collects information through software sensors, hardware. I don't think this one has hardware sensors, but generally collects information and adapts the learning path for the students. It's something that I suspect you are all familiar with. So I will move on. They have to apply the MAPK. And we arrive now at the first part of the diagram. This is a block diagram developed by the Magic Systems of Systems, and it is actually, and actually I'm planning to demonstrate that live so that you can see the tool. Yes. But I will have to change and hope, okay, I have been locked out. Oh no. Is everybody still here?
Yes, Sophia.
Yes, okay. Okay. I don't want to do anything detrimental, so I'm going to go back in again. Sorry for this. And what I will do is give you a demonstration how the tool works when you try to create some diagrams and how you actually connect the diagrams between them. Sorry, I have to connect to the. I have to connect remotely. Because for security purposes, yeah, that's the demo effect. Okay. For security purposes, I don't have a license on my computer, so I have to connect through Horizon. Oh, okay. So this is a project that is already has all of this information. So the high level block diagram is this. I think I might bore you by going into detail to this one. So I'm going to decide now to continue to do the next part of the slide, which is actually the demo video here, where you can watch afterwards. Oh, okay. So really, I should go in. I should either play the video or go in and do it myself. I think I'll play the video for a minute. Because for some reason I haven't printed it. 1 minute. I'll it will be short, and on the next one I will do it live.
Sorry, should we be hearing something as well?
Oh, yes.
So there's no sound.
Oh, Okay.
You may
Thanks
have to reshare your screen, and when you share the screen, there's an option to share your computer sound as well.
Is it working? Is it working or?
Can't hear any sound yet, no.
Okay, maybe I can do it live anyway. I don't know what I've done here.
Did you pick the include computer sound option?
Oh, yes, you're right. Yes, I'm not very experienced with that. I usually do it live.
Right.
And I want to interrupt myself while can you hear now? A lot of assistance as well, which sometimes is good. Most of the times it's good because it restricts you to create good model-based engineering. Sometimes it has been reported by students that was a bit problematic for them because they didn't know how to deactivate assistance. Anyway, we start. The first thing that you do in a block, you have the stereotype block, and then you just give names to all your blocks. So I'm not doing anything very important here. I'm just copying the names from an example I have. And it just saves with the name you give. These are always, these are similar, not actually similar. They are following the MAPK. So you can see that we have the virtual learning environment consisting of the data collection monitoring, which is the monitoring part of the MAPK. Then we have data analysis, analyze. I will explain why the name is like that. No particular problem if you don't follow this convention, but that helped in implementing the MAPK. Here, naturally, something else came up, which I'm going to demonstrate as well so that you understand the capabilities. Instead of going in here and start typing, you can double click in the element and then you get the specification of the whole block. This is one of the best ways to be able to fill in information in the tool because you have everything here. So you can type the name here, which was decision making / planning, or you can actually use ports, interfaces, behaviors, and add them through the description. So the specification contains everything. Also, the tool is offering on the right side some shortcuts which have the most common relationships and the most common things that you might need to do in your block. And another important part it has is this small plus sign, which is helping you to create compartments. For example, if I click here, I can add compartments into my block. So if I want to add a reference property or a value property, I can choose that compartment. And then I have the specific compartment and I can add my specific values. You can press this in order to suppress it and it doesn't appear, or you can put it back. You can put it back again. So value property, and then it adds some values. I can change all these, delete them, or add my own. And the other important bit is here. So if you are from this block, you will see what I'm going to delete this now because I did that as an example, really. I didn't really need a value in this block. So I'll finish adding 2 more blocks. This is the reconfiguration execution, configuration/execution. And this one is database knowledge. And what we will do next would be to, as we gave the simple names, we have for this one to add 2 parts, which one is the simple activity monitoring and the complex activity monitoring. So I will go to the part property, and the part 1 will be the simple activity monitoring. And the second one will be the complex activity monitoring. That is from the sensor factory pattern. And what I will do next is I will try to create the relationships. One way is to go and see here what relationship I want and drag it from here and drop it. Or I could go to the quick menu here and take the directed composition that I need between this one and this one. And then that continues with this one and this block. And I continue with this and this. And there is one more left, which is these two. You can see that the tool is actually does the positioning and things. So if I move, everything moves. And the other relationship that I need to do is the uses relationship, which was kind of used from here. So all of this, you depict that they are actually using a database. So in a few minutes, I have finished a correct diagram. And one more that I have not added is that this one has a part. So I will add the compartment, which is called tutor. And with a save all, I have finished my diagram. Let's see a bit of housekeeping here. You can see your diagram here, but at the same time as you create your diagram using the create diagram option, in here, you can see that it has created a set of models, and it has actually taken all of the blocks that you newly created and put them all in here in the model, and has created the relationship as well. These are the model elements which are different than the diagrams. So once you create the diagram, it automatically creates model elements on the left, and the model elements in your housekeeping of your whole project. Parts of these model elements, you can drag and drop them in other diagrams, but that will be the next. I will demonstrate that in a following video. I will stop this now and okay. Yes, hello. Are we all here? Yeah.
Yeah.
Hello,
Here.
guys. Okay, I think
Yes.
because I will start correcting myself here at some point. I'm not sure if you noticed it. Instead of deleting a value, I brushed it under the carpet by hiding it. So I'm not going to play any more videos, but I will continue and do some live ones. I hope this information was easy to understand up to now. I cannot see your faces, Guy, and it's very difficult to talk and train if I don't have any feedback.
Yeah, absolutely.
Okay, shall I move more quickly now then? Okay.
Yeah.
So, and maybe that might be a point that's not so easy for you, because I suspect that a basic usage of a block diagram should be easy. The sensor factory pattern is one of the patterns from the adaptivity patterns that need to be applied. And the main idea behind it, it has this block diagram in UML. And the main idea that is behind it is that on top of the sensors that you have, like complex, simple sensors, clients, you add some management layers. And these management layers help you to create a dynamic invocation of sensors at any time. Like you add information about what sensors you have, and you can turn them on and off from where they are needed. Does this make sense?
Yep.
Yeah. Okay. So that is the basic. Let me go to the correct slide. The idea behind the sensor factory pattern, you add some management blocks like the sensor factory register and a resource manager. And that is the drawback and the problem, the addition you make, but it gives you flexibility to be able to manage them even at runtime, to be able to turn them on and off, to be able to use them dynamically. And in every of these patterns, there is a second diagram, which is the sequence diagram, which depicts how they work. And there is another part, which I don't include in any teaching, but it exists in the patterns, the formal methods part, where it tries to say that these patterns are proving specific properties. So, this is kind of an overview about the pattern, and this is the one that needs to be applied. So then we move on to, this is a block diagram that is actually implements that pattern. And this is the corresponding sequence diagram. Here I had prepared another video, but I cannot continue listening to myself. So I will go and go into demonstration, but not the full preparing the whole diagram again. Oh, it brings me to this stage again. Sorry, I'll have to get you to see the login process again. I will take the block diagram as given, and then I will create the sequence diagram and connect it with the block diagram to show how the two diagrams are connected in the tool. This is one of the parts of model-based engineering, which I think is quite important, and students and people cannot get it unless they use a professional environment. But I am not sure what is standard or not. That is the tool. The other tool that I have used is Eclipse Papyrus, where I didn't see these elements. So what we are going to do, so that you don't hate me as well, this is the block diagram, and it does have already a corresponding sequence diagram, but I am going to create the sequence one again. And I hope it's here. Yes, you need to change view sometimes for unknown reasons. So I created the sequence again, and what is very important is that when you are starting a new diagram like the sequence diagram and you want to more or less associate it with a specific block diagram, one, you start by the name, so sequence, which can be anything. My naming is not the strong point here. And in order to add blocks to this diagram, you need to move to the model where you have all of the model elements, and then choose the model elements that you want them to be in your block, in your sequence diagram. So one of them is the student model. So you just drag and drop things like the activity, factory, service. Then we go to register. Ideally, you should be doing this today, as this is a training. But anyway, activity manager and simple activity monitoring. So that way, by dragging from the model elements and putting them in the diagram, you automatically connect what you had in your block diagram, which was the monitoring one. Yes, so you connect parts of it with your sequence diagram. I am here in this sequence diagram. And if for any reason you are in your collection here and you change the name and you call it, you want to just change the name, then automatically it changes here as well. And that is the point that model-based engineering can be helpful. And if you change the name in here as well, then it will change it everywhere too. This is a demonstration of how the model-based engineering can actually handle many diagrams, because here we have 2 diagrams, 3 diagrams, 4 diagrams, but in a big model-based project where you will have an industrial one, you might have 500 diagrams, and it would be a lot more to handle. Yeah, sorry. So that is something that from the teaching experience at the masters for this, I am not sure that people are getting, but I consider quite important to get, because it is actually giving you the benefit of model-based engineering in big projects, this synchronization, and it's very, very important. I keep repeating always the difference between having a diagram and having the containment here on the left. My experience from this has shown a lot of times as well that students are actually end up having one project per diagram because they get confused with this containment on the left. But when they do that, they are actually not getting, they are actually using this tool as a drawing tool and not actually getting any model-based benefit, really. So that is one of the important things that I want to emphasize today as well, about the synchronization and about the model elements with the diagrams. And there is one more that it is many years ago that I did the Eclipse Papyrus work, where in order to create some simple diagrams, it took me a long time. It might have improved a lot on the mean since then, but I cannot recall this feature happening there. Anyway, I'll demonstrate that so that you can we can discuss, and you can see, we can discuss if you think it exists or not. But that's something that made me quite happy when I saw this tool. When you start drawing your sequence diagram, you start having synchronous or asynchronous messages. Here I created a synchronous, I could, I think that's a return one, if I'm not mistaken. If you are not specific how you press, it creates a new element. So you need to just press at the correct time. So that is supposed to be a return message. And here you are creating a message to go. I will give it a random name here. And what you can do is, this is a message that goes from the student model to the activity factory service, which has remained 12. Sorry. So this is a message that goes from one block to the other. According to the SysML standard, when you have a synchronous message that goes from one block to the other, there should be an operation in the receiving block. And that is something that SysML requests. Now, one way to do that is to go manually in the original block diagram here and actually go to the factory service and add the operation. How would we do that? We would just add an operation here. But the thing that the tool is offering in order to connect things is when you press on this circle next to the message, and then there is something automatic which is called usage in diagrams. You click check other diagrams. And if there isn't any delay or any mistake that I've made, we can go back now. And this request one should be an operation in the activity factory service. And it should have been created automatically. And it didn't, it actually did it. So that way, you can be in your sequence diagram, create messages, use this clicking here and usage in diagrams, and then your block diagram is automatically being updated. Now I did it twice, so I have two requests. One, it automatically updates the information and what it should be there. There is another, not only the operation for the synchronous messages, for the asynchronous it is a signal. So likewise, when you have an asynchronous message, you go and you create automatically the signals in your sequence diagram. And it's one of the demonstrations of how the diagrams can be connected between them. And it actually, if that happens in other environments or how it happens, I would be interested to hear. On this specific environment, it gives the option to prove that how you are going in a project, a model-based project, you create your block diagrams, you create your behavior diagrams, and you connect them not only by you putting the same names on things, but automatically by the tool. This year, while I was running this session, I have heard complaints from students as well about the initiatives that the tool is taking, because as the versions progress, they are trying to provide more and more automation. And that sometimes doesn't offer them a lot of learning experience because they have the automation, but they don't know what to do with it. But that is a comment that I have heard from experience. The basic things, though, that if they haven't learned, I consider if that need to be used by any model-based engineer is to connect the diagrams and to be able to handle the model on the left to synchronize all of the diagrams on the right. Of course, there are a lot of other capabilities, like some simulation traces, which I haven't actually tried, but they are not, they are giving you some coloring of the simulation and how it runs, but they would be very interesting to run, but that specific unit is actually covering quite a lot in itself. So that's all about connecting diagrams, and there is a live video you can watch, which probably says different things than what I said today, but it doesn't matter. The gist is the same. And here I have some exercise which I would like everyone to do. And it's about, it's very simple, and it's actually the same idea as when we were discussing about plagiarism in model-based diagrams. So really, I'm asking people to plagiarize the patterns in their diagrams, meaning have the pattern at the right and change the names and apply the idea on the left. Do you understand my joke about the plagiarism? Probably I'm the only one. Anyway, sorry. Yes. So what I would like you to think for 5 minutes, if possible. Let me. And I will not do it for every single pattern, but I would like that to happen once. Is to find how can you plagiarize that pattern on the right? Well, it's actually been done, but I want you to do the reverse and just tell me which of these correspond to the pattern. The pattern is the sensor pattern, where it adds a management layer to your sensors. So it adds a bit of storage and management in order to be able to dynamically handle your sensors.
I suppose activity is the equivalent of sensor.
Wait a minute, Dimitris, I need to see my solutions. I don't remember by heart. Yes, yes. Activity, which one? Activity manager or activity factory service?
So sensor factory is, I suppose, activity factory service?
Yes, yes.
Yeah, and the registry.
Register, the registry.
Yeah.
Then
when you have simple sensor.
Yeah.
That would be the simple activity monitoring.
Yeah. Yes. Yeah. You are a very good student, Dimitris. Yes.
Thank you very much. I hope
it doesn't
get a passing mark.
Oh, you don't know how many times I struggle with this.
Okay.
Yes. So
this
is actually changing. It is actually an exercise in understanding the pattern and then changing names. So this is the answer, really. So Dimitris did 10 out of 10.
Yay.
And yes, and that is what is giving in the design adaptivity. So you have adaptivity at the architecture level. That's all they have to do, but in every layer. Yeah, but it seems to be something I struggle very much to get across. This is another pattern, which is called some of these patterns, they are a bit simple, I would say. So in practice, when we are actually designing such things, we might even use combinations of these in order to provide value. So each of them, they have simple ideas, but the innovation could happen when an appropriate combination of them is used. But that is quite advanced subject, so I can't manage to get students to understand that, because it is actually a subject for a very experienced engineer in order to create a new one that would either create a completely new one or have a synthesis of the above. This is another one, which is the adaptation detector.
I'm sorry,
pattern.
I will have to drop out because I have another meeting to join in 15 seconds. But thank you very much for this introduction.
I'm losing my good student then. Where is everyone else? Yes.
Sorry about that. Bye. See you soon. Bye.
Yeah. Okay. Bye, Dimitris. Bye. So this is the adaptivity pattern, the adaptation detector pattern, and its idea is about using how you create triggers. So you have a health indicator and an analyzer where you actually define thresholds. So you are monitoring data and you are seeing if something goes out of bound, out of limits. For example, if you monitor blood pressure and it goes over 20 or a specific limit, then there is a trigger. So this is quite of a logical thing that you would do in your design anyway, but the pattern is giving you structure. And also here you see how you store the data and you use hardware and software sensors to produce the data. This is the sequence diagram of the pattern, and I will. This is the block diagram of this particular pattern, and there is an exercise, but I think if someone wants to have a go, I'll leave it. Otherwise, I'll give you the answer quickly. Am I left with Nuno only?
Yes, Sophia, but keep doing it for the recording as well. Yes. Keep doing for the recording so that people, when revisit it, I'll be able to do it. So if you want to skip right ahead to the answers, that's fine, because people that will be doing it at home can stop the recording at any moment and do it for themselves.
But I will stop asking you because
yes.
When they understood that there's going to be assessment, they went anyway. Yeah. So I'll continue, assuming they will watch later. So this pattern is actually the adaptivity pattern, and the answer to this is that the trigger is the tutor in our model, the health indicator is the performance indicator, the observer is the action repository, and the analyzer is the performance analyzer. Then we have the case-based reasoning pattern, where you have a set of fixed rules, and then we have decisions that are being made and triggers. And on the right side, you can see the learner and the log, where this model can learn from from data. From time to time in these patterns, you can see that there is learn and log, where you make your model clever by learning. And we continue with the pattern now, and here is the block diagram of this pattern, where you see the decision making, the business rules, the logs, the action, and the decisions, which is kind of a renaming, a simplification of the previous one. And here we can see the sequence diagram that is here. Now, the application of the pattern, it's again a naming thing between the inference engine, between the pattern on the right and the block diagram on the left. And if there are any questions understanding this, I can answer them at another point. Oh, I'm nearly at the end, actually. And there are connections between so important for a commercial tool is to have the connection between the diagrams, to be able to justify how you have the model versus diagram, so the left pane with the right pane. It's very important to support most of the standards and to have some other capabilities as well. the adaptive patterns as a reflection is that they are to make the system smart, and you have to be able to apply ideas, which I call plagiarize here. And that's all, I think.